All right, welcome to unit, oh my gosh, change over time unit, lesson number 3. Let's try this again. No, welcome to unit 3 on artificial selection. At this point, you should have completed both your lesson on adaptations for lesson 1 and lesson 2 on natural selection. Today, we're going to look at artificial selection, which is essentially humans taking over and picking and choosing what gets to survive. So we're going to look at what is artificial selection. We're going to look at artificial selection through the years, and we're going to look at a little bit of a difference between selective breeding and genetically modified organisms. So let's go ahead and jump into our notes for today. Once again, change this darn thing. Come on. Okay. So artificial selection. So if you remember, natural selection is where organisms that are best fit for their environment are going to be the ones that survive and reproduce and pass their traits on to their offspring. It is nature doing the selecting. It's not, you get to survive and you get to survive and you get to survive. It's saying that those best adapted are the ones that are more likely to survive, okay? Artificial selection takes that and flips it 180, turns it on its head, and says, nope, only the organisms with the desired traits get to be bred. It doesn't matter how well you are adapted for it, it's traits that humans want. So humans are going to be the ones driving artificial selection, whereas nature is the thing driving natural selection. So once again, artificial selection is driven by humans, whereas natural selection is driven by nature. 2 types of artificial selection we're going to talk about is going to be something called selective breeding and GMOs, or genetically modified organisms. Put that video up later. You can watch that. Okay. So first one, selective breeding. Selective breeding is going to select already existing traits. So the traits have to be there in order for humans to want to boost those traits up a little bit. Okay. So selective breeding selects already existing traits by breeding individuals that have a desired trait, while genetic engineering, so GMOs, is going to actually go in and change the DNA of these organisms by either introducing new genes or silencing genes that are already there. So actually going in and manipulating the genetic makeup of these organisms, whereas selective breeding is just saying, hey, I like that trait. Let's get it bumped up and I want to see more of it. Okay. So we're going to start off with selective breeding. And if you are a dog owner or anything like that, you should be familiar with the concept of breeding dogs for specific traits. So this is looking at how dogs have been domesticated over hundreds of thousands of years. The common ancestor of all dogs is the gray wolf. And what humans started doing is they started kind of forming a symbiotic relationship with wolves, in that the wolves would start to come in around human civilization because humans would leave out food and things like that. And as the wolves started coming in and getting familiarized with the humans started realizing, well, we can use these animals to be protective and things like that. So they started domesticating the wolves, and then they started breeding them specifically for traits that they wanted to have. So over hundreds of thousands of years, we start to see dogs and wolves being domesticated in different areas for different traits. So if you look over here, we have different ones bred for Europe. We have different dogs bred in North America, in China, and in India, until we get the hundreds of different dog breeds that we have nowadays. These are all done through selective breeding, picking what traits you want in the offspring, and then choosing parents that have those traits and only allowing those parents to breed. Okay. So for example, we have a dachshund here, weenie dogs. Out of these 4 things, which one do you think a weenie dog was originally bred for? For hunting lions, being a guard dog, chasing rabbits down holes, or for royalty to rest their feet on if they have like nice little feet rest there? So dachshunds were originally bred to be a hunting dog, okay, to go out and chase rabbits down and out of holes. Now, normally nowadays, we would not take a dachshund out hunting with us. We want something like a lab, or I don't know what else you take on. My family has labs. So, but a dachshund was originally bred as a hunting dog. If we look right here, this is change over the English Bulldog since 1800. So about 200 years worth of selective breeding here. If you look at the skull of the English Bulldog in the 1800s, you're going to notice that, oops, where's my thing here? I want you guys to notice the difference in the height of the skull, okay? The nasal passage. So if you look in the 1800s, this dog has a decent nasal bone right here, but then in the 1900s and modern one, notice how deep in its nasal bridge has sunken. You guys ever heard a bulldog try to breathe? It's because its nose is all smushed up into its face. It has no nasal cavity to breathe through. If you also look, humans have significantly increased the underbite for these dogs, and it's moved its jaw back quite a bit. So see right here where the upper jaw is in the 1800s, where it's gone in the 1900s. All right. So this is an example of selective breeding. Humans breeding these dogs to get to specific traits, and how we've changed these dogs over just a few hundred years. All right. So right here, this is a gray wolf skull. This is the ancestral dog. I want you guys to make a prediction. What kind of skulls do you think these dogs belong to? I'll tell you in just a minute. This one's a pug. You can see it's got the squished in face, itty bitty little round skull. It kind of looks like an alien skull, doesn't it? Then we have this one right here is a Rottweiler. And then the last one is a golden retriever. So I want you guys to just take just a minute and look at the similarities that we see in here between the ancestral wolf and the other skulls. So out of these three, personally, I think that the golden retriever skull looks the most like that of the gray wolf. And obviously the pug has made the largest deviation from what the gray wolf was originally. The Rottweiler, you can see it's got a much higher skull right here. It's got a more pronounced slope of its snout right here. The golden retriever, I don't know if it's just because he didn't go to the dentist very often or whatever, but he's missing some teeth in here. But you can see he's got kind of the same nasal ridge right here as the gray wolf does. His teeth are not as sharp and everything like that and meant for predation anymore. The eye socket is very similar in the gray wolf versus the golden retriever. But just think of the purpose that each of these specific dog breeds has been bred for, and what traits that people would be looking for in things like a Rottweiler or a pug or a golden retriever or anything like that. Artificial selection was also big in the 1800s, like Charles Darwin, who we've talked about, loved to raise pigeons, and they would go to pigeon parties and everybody show off their fancy pigeons. So you can see right here, these pigeons, one right, the bottom left one has been bred for very pretty tail feathers. The one in the middle has been bred to have a very large crop on its neck. The one on the far right has got a very pretty head feathers and things like that. The auroch, we talk about a lot of cattle, livestock domestication. The auroch is the ancestral cow. It is from Europe, and through thousands of years, we have domesticated it and turned it into things like the Angus cow, which is where a lot of beef comes from, Hereford cows that are found in England, dwarf Angus that are used for pets, Brahma cows from India, and then Oreo cows, Holsteins that we get milk from. And all of these come from, just like the dogs do, they come from the ancestral auroch, just like dogs come from the ancestral gray wolf. All of these vegetables right here, your cauliflower, broccoli, cabbage, kale, kohlrabi, is all from one plant. And by looking at specific parts of the plant and breeding specifically for those parts, we have created 5 different vegetables from one plant. So for example, the cauliflower comes from the flowers. Broccoli comes from suppressing the flower growth. Cabbage comes from these little nodes between the flowers and things like that. If they make those grow bigger, that's what makes cabbage. Kale is obviously from growing these leaves extremely large and things like that. So from one plant, we have gotten 5 different kinds of vegetables just through picking and choosing which plants get to breed with each other based on what traits we want to develop. Another video up in here. So a little bit of looking at how we've done plants over the years. This right here is a picture from, I think, the 1600s. This is a picture of watermelon. I don't know about you. I don't like watermelon myself, but if I went to a picnic and saw this on the table, I think I'd be pretty upset. Okay. It looks a lot better now. If we look at how watermelon has changed over the years, humans have been growing watermelon for approximately 5,000 years. When it first started off, it was in small parts of one part in Africa. If you look at kind of the information over here, there were only 6 varieties of it. It's very rich in fat. It's very bitter. You had to smash it with a hammer or a rock to get it open. 80% water, 2% sugars, 18% starch and fat. Now we can grow it in North America, South America, Africa, Asia, a couple places in Europe, not so much in Australia. You have cream watermelons, yellow watermelons, green, red watermelons. The biggest difference, if you guys look here, is we've increased the water percentage by 11.5%. We've increased sugars by almost 5%, and we've decreased everything else down to only 2%. So we've taken out the starches, we've taken out the fats, we've increased the water content, we've increased the sugar content to make a much more desirable fruit. Same thing here goes for peaches. If you guys are familiar with little teeny tiny sour peach or sour cherries, my dad used to grow those when I was little. They were horrible things. But ancestral peaches were located only in China. Okay. 71% water, 8% sugars, 21% other. Okay. Now, 6,000 years later, it's North America, South America, Asia, Africa, Europe, Australia. There's over 200 varieties of peaches. We've increased the water content upwards of 17%. The sugars have stayed the same, but they've made it 4% sweeter. And then they've decreased that 21% of other stuff down to 1%. Okay, take a wild guess as what this thing is. So this is a banana, ancestral banana, new banana. One of the things I want to talk about right here is one of the downfalls to artificial selection. Right here, this is called the Gros Michel banana. This is what artificial banana flavoring is taken after. The chemical composition of artificial flavoring is modeled after that of the Gros Michel banana. I love artificial banana. Artificial banana Laffy Taffies, those are the best thing ever. But unfortunately, because all of the bananas that we have in supermarkets are clones of each other, because once they find a strain of banana that grows well, everything else is cloned, okay? Well, the Gros Michel banana was popular back in the 1940s, 50s, and 60s until a banana fungus came in and wiped everything out. They could not grow enough Gros Michel bananas to keep the supply up. And so the Gros Michel bananas were taken off supermarkets because they couldn't keep up with demand for it, and you can't really get them anymore, which is why nowadays we have this banana called the Cavendish, and it doesn't taste anything like artificial banana flavoring, which is essentially modeled after a somewhat extinct banana. Now, the Cavendish banana was able to survive and withstand the banana fungus that killed off the Gros Michel. But once again, all of these bananas are clones of each other. So if we have another disease, virus, fungus, or anything like that that comes in, and the Cavendish banana is susceptible to that, what happens to all the Cavendish bananas? Gone. Because there's no variety in them. Remember, we have to have variety in order for selection to work. If there's not enough variety, things die off exceptionally fast because there's nothing else there to survive. So the bananas is kind of a learning point with artificial selection in how easily something that has been chosen for specific traits can be wiped out. Okay. So here's just a little bit about the bananas. Like I said, the Cavendish cannot reproduce sexually. They have to reproduce asexually by reproducing themselves. And this is 99% of all the bananas that are exported to developed countries is the Cavendish banana. Okay, a little bit before and after. This little dude right here, let's take a guess as to what it is. This is an eggplant. This right here that looks like you just went and dug it out of the ground is a carrot. This is what my grass looks like in the summer when I don't mow it every week or so and it goes to seed. You get those little tops of your grass that look like wheat. This is ancestral corn. Okay, so domestication of corn. We've been domesticating corn for upwards of 9,000 years, specifically in Central America. So the original corn was only 19 millimeters long. So it's only 2 centimeters. Okay, not very long at all. You had to hammer it with a rock or anything like that to get it open. It had to taste kind of like potatoes, not great. And so as people in Central America started to domesticate the corn, they started developing all these different varieties. And 9,000 years later, we have upwards of 2,000 varieties. It comes in 5 major colors. It can be grown virtually anywhere across the world. If you look at the different components of everything like here, the water percentage has gone down since we've domesticated it, but the sugars have increased from 2% to 6.5%. And then we've kept the starch and everything like that right about the same. So really what we've done, we've decreased the water a little bit and upped the sugar levels and things like that. Okay, now, selective breeding back. Remember, selective breeding. We are only picking the organisms with traits that we want and allowing them to breed to get what humans want and what humans need. GMOs is going to be another different thing. So a GMO, a genetically modified organism, are living things that have had their genetic code changed in some way, whether we've gone in and deleted genes out, we've suppressed genes, we've added new genes in. Everything is done through altering the genetic code of these organisms. So, for example, bacteria, we watched this in our Bill Nye video a while ago, have been genetically modified to produce medicines that can cure diseases. So we can put a gene inside bacteria that will actually make it produce insulin, which would be beneficial for people who are diabetic because their pancreas doesn't produce the insulin that they need to break down blood sugar. So for artificial insulin that's not produced by humans, we can actually make bacteria produce it by adding a gene into their genetic code. Okay, crops, this is a big deal in Wyoming here, have been genetically modified to be both pest and herbicide resistant, which means that they're not going to be susceptible to bugs coming and eating them. And they're resistant to herbicides, which means that farmers can go in and spray their entire crops with weed killer, and it'll kill the weeds, but it won't kill the plants. Okay. So for example, we are growing corn that is resistant to an herbicide called glyphosate. We have alfalfa sprouts that are resistant to Roundup. In places like Hawaii, they have created papayas that are 90% resistant to something called round spot virus, which, like the Gros Michel bananas, wiped out a good percentage of Hawaii's outputs of papayas, which is a huge blow to the Hawaiian economy. So this is what round spot virus looks like. We have made glow-in-the-dark animals by taking genes out of jellyfish and introducing them into these organisms' DNA. Why? Because we can. Examples of GMO. So in 1944, the average cow produced 548 gallons of milk per year. Through both selective breeding and genetically modifying these organisms, we have now made cows that produce upwards of 2,500 gallons per year. So we have essentially made them produce 5 times the amount of milk that they normally would. We have made cows that are less farty, that produce less methane, because scientists have been able to go in and sequence the genes of the bacteria in their gut that produce the methane and have figured out ways to decrease that type of bacteria. They have created, actually I had a friend in UW who was in on one of these studies where they have made goats be able to produce spider silk in their milk. And the reason they do this is to test the tensile strength and things like that of the spider silk, because it's so hard to get spiders to spin silk. So if they introduce these genes into the goats' bodies will produce spider silk in their milk that you can actually go and take the spider silk out and have a lot more silk there for research than you would just by spiders spinning it. Okay, so the things that they use this spider silk for are to make artificial tendons and ligaments for people who have amputations or need to have them rebuilt. For eye sutures, so if you cut like the cornea of your eye or anything like that, they have to go through and stitch it down. They will use spider silk for the sutures or the stitches in your eye. For jaw repair, because you need something that's going to be very, very strong but flexible as your jaw heals. So they'll use spider silk if you have a broken jaw and it needs to be stitched up back here in your joint. They also use it to produce bulletproof vests with the research behind Kevlar and things like that, and to improve car airbags. So ones that are more flexible but stronger in the event of car crashes. Another example of artificial selection is the Aqua Advantage salmon, which they've taken a gene from something called the Chinook salmon, which makes it grow a lot faster, which means they can produce more fish in a smaller amount of time, which means you have a higher output, which means that these salmon farms can make more money by producing more fish. I'm going to skip all this because this is an activity we're not going to do. All right. So one challenge I want you guys to do is on your note page, I have set this setup for you. I have labeled it A to Z for you. And I want you to go through and I want you to see how many letters you can come up with organisms that humans have either done artificial selection for, meaning selective breeding, or have been modified into a GMO. Now, these have to be ones that humans have directly influenced. You cannot just go through and put things like lions for L, because humans have not done any artificial selection, selective breeding, anything like that with lions. All right. Now, could you do A for apples? Absolutely. Could you do B for bananas? Absolutely. Okay. So think of most fruits and vegetables that you see in the supermarkets nowadays. Those have been through artificial selection. Anything that we have domesticated, cows, sheep, dogs, anything, cats, anything like that, we have worked through artificial selection with that. So this is my challenge to you. Once you have your A through Z list done, I want you to go through into your mastery check, take your lesson 1 mastery check. And if you have any questions, come find me. Otherwise, once again, good luck with you.